In this video, we will show you how you can create and maintain joins. In the previous page, we have explained to you what are joins and what are there are different types of joins and why there are different types of joins, and also why the joins shall be different. The joins master data can be accessed from settings, joins. So this will give you a screen which will show you the joins that you have created for this group. As I told you before, we have created a test group as part of this demo, and we have already defined in the previous videos how you have defined the parameters for this test group. If you want to take a look on that, if you go to settings and measurements, I have defined a set of parameters which are applicable for this test group. Again, there is a penetration, there is a metal thickness, percentage penetration, leg on base metal. Again, penetration 2, welded metal thickness, percentage on welded metal, and leg length on welded metal, actual throat, root penetration, mean thickness, and max thickness. If you look at it, we have already discussed about the derived parameters. We have four derived parameters: percentage penetration 1, percentage penetration 2, mean thickness, and max thickness. We will discuss in this video how we are going to define them also. Now coming back to the groups window, now we are going to define a new joint. Now to create a new joint, click on new joint. It will ask you a name and say all my parameters are applicable for T joint. I can click on all. This will move everything to my T joint. Or I can select specific parameters and move one by one. For the demo, what we will do is we will select all the parameters. So I am just selecting all. Now all these parameters from depth 1 to max thickness forms part of this T joint. So we shall be measuring these parameters and reporting these parameters for all the joints in a component that are of type T joint. Remember, a component has multiple joints and each joints can be of different type. For example, if there are 10 joints in a component, 3 can be of T joint, 4 can be of butt joint, and remaining can be of V-groove joint. It will be always a combination. We also discuss about derived parameters. Now, if you see there are four derived parameters: percentage penetration 1, 2, mean thickness, and max thickness. Now we are going to define or set the formulas on how to calculate percentage penetration 1. So first I will do, I'll select that one. Set button is there. So I get an interface where I can define the formula. I have mean operator, max operator, average, addition, subtraction, multiplication, division, and percentage. I will select here percentage, and I will say select this. It will be depth divided by base metal thickness. The percentage of depth 1 on base metal thickness will be my percentage penetration. There are also situations where some customers say my percentage penetration will be always based on mean thickness. In that case, it will be depth 1 on mean thickness will be the percentage, and I set the rule. So the formula is set. Similarly, for percentage penetration 2, I set it. I select the percentage operator. It will be depth 2 over mean thickness. Set. Now you will define mean thickness. Mean thickness is what? It is the minimum of. So I select the minimum operator, minimum of base metal thickness and welded metal thickness. So system will, when you are entering the or from the master data, the base metal system gets the base metal thickness and welded metal thickness. The mean thickness will be automatically calculated. Similarly, max thickness, it will be the max of base metal thickness and weld metal thickness. So now I have defined the parameters and I also defined the derived parameters for T joint. Now I'm going to save it. Save it. So you get a message that successful. You can also create another joint, let's say butt joint. Here I'm not selecting all the parameters. All I have is there's only one leg. Let's say for this joint, these are the parameters as per the design. These are the parameters that are applicable for butt joint. So what will I do? I have selected only those parameters and I will define the formula for that. Let's say for depth 1 divided by mean thickness is my percentage formula. Again, I am doing for mean thickness, it is minimum of my base metal and welded metal. So I now define the butt joint. So I'm going to save it. See, I have defined two joints, a T joint. These are the parameters applicable for T joint. And there's another joint, butt joint. These are the parameters applicable for butt joint. Right? That's it. So once I have completed my definitions, I can close it. If you want to edit it, you can always come back later and edit it and change or add new parameters or change some parameters or even change the definition of the parameters. You can always come back and edit and change it. Once we have made any changes, we have to save it, close it. So this is how you will define the joint types. Joint types define what type of a joint you have in your component.